section. So we'll be having a talk on provisioning IdM clients in OpnStck. And the bio of the speaker, Rob Crittenden, is a principal software engineer in Red Hat, working on security in OpnStck. In this session, you will be getting an overview of certificate management issues in OpnStck instances. So please, over to you.
All right, so as he said, my name is Rob Crittenden. I speak very quickly. I did a speed run of this talk in about 3 minutes last night. So if I start going too fast, let me know. So I'm also loose with language. I use a lot of acronyms and things, so let me just go over some stuff so you can follow along. So when I say instance, I mean an instance in Nova. This could be ironic or a VM or whatever. I try and not use the word server because then that gets too confusing. Cert and certificate I use interchangeably. It's X5 and IV3 certs. And then IdM, IPA, and free IPA are all the same thing. So what is auto provisioning? What I mean here is I want to be able to launch an OpnStck instance and enroll it as an IPA client. The reason I want to do that is for OO. OO is OpenStack on OpenStack. And the idea behind it is that you deploy one cloud, and from that cloud you deploy your production cloud. And this gives you a lot of benefits, and I encourage you to look into it. I don't want to have a OO talk, but when I deploy that production cloud, I want TLS-enabled endpoints on it, for TLS everywhere. And the question is, where do we get the certs from? I can push them in using Ansible or Heat or Puppet or any number of other things. But the problem is then the private key exists outside the OpenStack deployment and inside. And you normally don't want private keys floating around. Another alternative is to pull them in somehow. And I'm going to use CertMonger. And CertMonger is a service for requesting certs and managing them. But the thing about CertMonger is it requires a credential. You have to prove who you are, because you're already inside this booted instance, and you want to get something from the outside, and you have to prove who you are, that you're not just some random schmuck. So these are the two questions I had to answer, like how do we automatically issue the certs? So we need a CA, obviously. And then instances in OpenStack don't last very long, typically, right? So we need, when they go away, we want their certs revoked, not just deleted because we don't know what happened to them in the meantime. We want them gone. Assuming you're OCSP or CRLs, shouldn't be usable anymore. So these are the tools I had. I had the Nova metadata service, CloudInit, free IPA, and CertMonger. So let me go into each of those. So metadata service typically has been static up to about Newton. It had things like the instance name, the UUID, the image it's booting from, a bunch of other information. And it also has user properties that you can set when you launch an instance. And they can be whatever you want. It's freeform, just name value pairs. And they're available by this magic URI from within your OpenStack instance. And networking handles that only that instance can get that instance data. And it's referenced by date, and the date being the date of a new OpenStack release, typically, or the word latest if you always want the newest stuff. It's the way they handle API and backwards compatibility. And there's two things you can get. You can get userdata.json and metadata.json. I'm going to focus on the metadata. And they also say there's a new thing with Newton called dynamic metadata. So we had an implementation of what I'm going to talk about in a minute, fully working in OpenStack using this thing called Nova Hooks. And Nova Hooks, there were 6 places in Nova you could write a plugin to access internal data and really get total control over the Nova internals. We filed a bug against one of those things that wasn't working. They were that this thing existed and immediately deprecated it. So we had to come up with another alternative, and they wrote dynamic metadata. So rather than static metadata, which is all fixed and generated by Nova, they wrote a REST API. So their client calls a REST server, posts a certain set of functions or methods, and you can get data back. And they just pass the data along. They don't interpret it at all. It's just JSON. And this is how we're going to get information from IPA into the OpenStack instance. CloudInit, it's like first boot for cloud images. It can do all kinds of cool stuff. It can install packages. It can write arbitrary files. It can update your DNS settings, set your host names, and all kinds more. So we're going to use this to do our enrollment. And then free IPA is centralized identity. So it comes with a CA. It's optional. In our case, it's mandatory to manage SSL certificates. It has host-based access control. I can never say that. That's going to become interesting later. Centralized sudo, also going to be interesting later. It has Kerberos, which we don't need right now, but you never know. And clients can enroll two ways. They can enroll using a username and password or a one-time password. And if acting as a DNS server, then IPA can handle the floating IP assignments within Neutron. And finally, CertMonger, all it does is manage certificates for you. So it can request certs. It knows when certs are going to expire and try to renew them for you, so you don't get that 2 a.m. call on Christmas morning saying, my server's down. I think we've all been there. So this all led to the NovaJoin project, or the second generation of NovaJoin. It's two servers. One is a REST API, which handles the hosts from Nova. All it does is add host IPA. So it generates a host name based on the instance name plus the IPA realm, or domain name, and then it generates a random one-time password. And it adds that to IPA, and then sends the password and the host name back through the metadata. And it's got a notification listener, and so whenever something interesting happens in the OpnStck, it generates an AMQP notification. For I'm creating a host, the host is being added, the host is done being added. And so similarly with deletes. So when we see that an instance has been deleted, we try to delete that out of IPA as well. And that's going to revoke all the certificates as well. And I have a limited amount of support for floating IP assignment. The last time I tried it, it worked. But things are always changing in Neutron. So I recognize that not everyone's going to want to enroll every single instance in IPA. So I added a trigger. So if you set the property, our IPA enroll is true, when you launch the instance, then it'll enroll as a client. But that's kind of manual. You have to remember to do it. So you can also set metadata in an image. And if you set this property in the image itself, then every instance booted from that image will enroll in IPA. And there's another requirement for this trigger. So right now, you can't set pass into the IPA server to use, so it has to be discoverable by DNS. It's probably not a big deal. Depends on what your DNS situation is. And you don't have to use IPA as your DNS. It's just that makes it nice for to get the reverse IPs added automatically. The minimum requirements for an image, IPA client, obviously. It's available in most distributions. I don't think that's going to be a problem. And you need a cloud in it of greater than a certain version for config drive because it's broken before that. And it can't read config drives. So we also have a cloud in it. And this cloud in it first installs the packages we need. It fetches the metadata out of Nova, parses the JSON, and then just passes that information to IPA client install. IPA client install, we use DNS discovery to find your IPA server, the domain in the realm, and do the enrollment for you. And so it looks pretty simple. You just do the start an instance creation, and a few minutes later you have an image enrolled in IPA. And this is what it sort of looks like. So here's a typical OpnStck deployment. We have a controller, one or more compute nodes, our free IPA server sort of hanging out. Within this controller, I'm kind of simplified a little bit, just showing the things that I care about. So we have our Nova API, our Glance API, and then the joint services are sort of bundled together. So here our user is creating an OpnStck instance, and they pass IP enroll equals true. So Nova goes ahead and launches the instance for us. And this may take, 2-3 minutes. Once it starts to boot, Cloud Init fires up, installs IPA client package, and then makes a curl call to our magical URI. And this is going to trigger the REST call. So we get a post with the instance name, a bunch of UIDs, the properties, and this is when NovaJoin kicks in. So the first thing we do is we check with the Glance API. We say, does this image exist at all? Because you never know. If it does, then we fetch the metadata out of the image itself. And if either the image says IPA enroll is true or the property is IPA enroll true, we proceed. Otherwise, we exit right away. So assuming it is true, then we generate the host name and the one-time password and pass that on to IPA as a host add. This is the command. IPA host add is the equivalent command line to what we do. And then we return all that to the instance metadata. This all happens in like a half a second. At this point, at this point, we parse the output, get the OTP, and do the enrollment. So now we have a full IPA instance ready to go. You can call certmonger to get a certificate or certificates for this thing, and then you're done. And so you go on your merry way and do whatever you want to do with that instance. Something to note. So config drive, this procedure is if you're doing metadata on a virtual machine. So in that case, the way the metadata works is it's really not generated until you need it, which you only need it when it's called. For config drive, Nova collects the metadata in advance before launching the instance, and it puts it in ISO format and sends it along when the instance gets booted. So in this case, the OTP is generated and it's going to sit out there for a while. I don't think that's a vulnerability because you can't do much with this OTP. It basically allows you to bind once to IPA and do one thing, join. So the worst, you could join IPA, which doesn't really get you all that much. And that's it. So when you're done with the instance, you delete it like you would. You don't have to do anything special. So you just call OpnStck server delete. Our MQP listener gets a notification that the delete's finished, and we delete it out of free IPA. Deleting a host out of free IPA deletes any services you've created for it, revokes any certificates you have for it, and otherwise generally cleans up. It'll also clean up the DNS entries as best it can. Yeah, I'm on a speed run here. So something. Oh.
I'll ask you a question.
Sure.
The two places to define whether or not enroll is true, IPA plan and join is true. Does one default, like one override the other?
No. If either one of those is true, it gets enrolled.
Okay.
Yeah. So if you set in an image that's true, it's always going to be true.
Okay.
So that we don't want the user to override that. So images are cheap. So this isn't something we're using right this second, but the idea is to use host classes to enable host-based HBAC, because I can never say host-based access control HBAC. So IPA has this concept of auto membership rules. So basically, if you set a class when adding a host, these set of rules are regular expressions, and if your host class matches these regular expressions, then it gets added to a host group. Now you can assign host groups to HBAC and host groups to sudo rules. So basically, you can lock down this new instance as soon as it comes up. So only maybe certain people can log into it, or maybe once they log in, they can only run certain sudo commands, or any number of different things. Now, I have a whitelist of allowed user classes right now, which isn't much, and it's not super flexible. But in case you had a host class for always allow people to sudo, we don't want that to be the default on Nova instances. So you wouldn't obviously put that in the whitelist. I'm going to make this more flexible in the future. This is still quite new upstream. We hope to get this in Okada. If not, then it'll hit Pike. OpenStack releases. It's really close. And that's, 15 minutes. So it's fine. Yeah.
Just out of curiosity, what was the thing you were doing with Nova Hooks that was so terribly deprecated?
Please repeat. Okay, what was I doing with Nova Hooks that was deprecated? They didn't like the idea of Nova Hooks at all. So, I mean, literally, you had access to the internal data structures of Nova within your hook. And all I was trying to do was inject metadata. And you could also list the files that you pushed into the image. And so I was just trying to concatenate that file list with another file. And all that file did was call IPA client install. And like I said, they were truly horrified and didn't like it at all, and it was up to me to come up with a replacement, and I didn't come up with this. The guy who came up with it said something rather rude at an OpnStck conference, and he felt so guilty about it that he came up with this as a replacement. So I love the Nova guys because they pulled my butt out of the fire. So, anything else? I have a demo. I'm not sure what it would look like up here. It's a recorded thing. It may be too small to read. I can show that if you want. It's like 2 minutes. All right. Let's see what I can do. Oh. I also have to figure out how to get this to play on that screen. Aha. It played full screen on my screen. Yeah, all right. Well, I can show it to anyone who's interested. But basically, like I said, it seems really complicated, but from a user perspective, they just pass a separate property, and it gets enrolled, and it's as easy as can be. Now, the reason we want this is because, like I said, we want TLS everywhere, and TLS. The previous talk mentioned that he had TLS working on all endpoints. Within the Red Hat OpenStack, we have it working within all endpoints except for Rabbit and MySQL. I have to talk to the previous speaker because he said he had it working with those. And it's always a problem where to get the certs. Right now, we pre-generate them and shove them in using Puppet. And like I said, that's kind of a nasty thing. So that's it. All right, thanks. You couldn't ask when they have.
No. So I was confused. Based on the diagram, it sounded like it is a pull from the machine to call a URL to trigger the IPA sequence.
Right.
Is that the case?
In a way, it has to get the metadata in. Yeah, that's basically it.
But you then said that it will sit for some time.
Only in the config drive. So if you're using config drive, which basically creates a CD-ROM of the data, and what it'll do is that's generated by Nova before it launches the instance. Mm-hmm. So it's
the
metadata
that's a different flow.
Slightly different.
Okay, so
yeah, the OTP is going to be vulnerable
Okay, so-
to some extent.
right, but it can be stolen only once. And
You can't do much with it, right? You can't bind and do calls or anything.
is there any kind of audit trail on, like, or plan to correlate just to make sure that the right thing actually happened?
So I think practically speaking, so you would notice, I think, because when you went to go boot that instance, it would join with fail because the OTP's been used. So you go, hey, why, you know. Now maybe in OpenStack people are used to things failing, they would just delete it and do it over. But if you saw enough of those, then people would notice.
Right, but there should be some kind of the audit trigger saying, wait a minute, it failed to enroll with the OTP, that's a security
That's bad,
breach.
yeah.
Yes.
I mean, I don't know what I can do from IPA client, from my script to set off any alarms.
You want to talk to Reach so that he sort of
Be aware of it. I think that's why
Yeah.
he had that question too. I think the same thing is probably knocking around in his head.
Yeah, so, well, we know that from the very beginning when we defined this flow, that there is a weakness in this flow, but it can be mitigated by proper auditing outside.
Right. Okay.
So-
I see what you're saying.
So we just need to make sure that the loop is closed, and that when we do like audit piece for like what Reach is doing with Alvara and others, that this is a triggerable event that can create an alert
somewhere.
that, well, this is really bad.
Right. Yeah, I think we'd have to augment IPA. Because IPA really should trigger that, I think.
Okay.
Like, an enrollment was requested with a bad OTP. We could have we could log that separately.
Well, the client also can do it in their own. It's like you might not be collecting.
You wouldn't be collecting new instance logs, I don't think.
Well, we will be collecting instance logs.
Okay.
So that's
Okay,
kind of
then,
the point.
yeah. So I could
Yes.
syslog something, I guess.
Right. So that's kind of making an alarming
Yeah.
message into syslog or whatever
Or
journal.
whatever journal is, yeah.
Yeah.
But
Yeah. Just I think that, and then letting the logging guys like
Yeah.
make sure that is captured and then
Yeah.
on the central.
That's a good
database,
idea.
They have an alert for that kind of thing.
Okay. Yeah. Yeah.
Hey, Dimitri.
We have to stay in line.
Oh, that. Sorry, I put your name.
No, I put my name. They just could. The schedule can only accommodate one name because they don't know how to do multiple names.
Yeah, that's stupid.
So the other question I have is, we have one mic. One mic.
Yeah, I'm guessing there's only one mic.
You guys have a clicker.
Oh, yeah, that'd be helpful.
No, that's something which was not passed from the previous group. I
Okay.
just took over, so
Okay, fair enough.
I came to ask what kind of introduction you want.
I think we can excuse ourselves.
All right.
Yes, but thank you for offering.
I'll be right here if you need it.
I'm gonna do the